In this video, I'm going to define a sequence. What is a sequence? From an ordinary person's perspective, a sequence is kind of like a list of items. We use this word in our daily life pretty frequently. So you have a sense of what a sequence is. It's a list of items or things. Now, in the context of mathematics, however, sequence has a slightly different meaning and it is defined more precisely. To put it simply, in the context of math, a sequence is a list of numbers, to be particular real numbers or numbers from number line, and this list of numbers is actually infinite, meaning that a sequence has infinitely many items listed on it. For example, here is an example of a sequence. Something that you have seen. 1, 2, 3. It's actually a sequence. It keeps going forever. Or I could give you another example. 1, 1/2, 1/3, 1/4, and it keeps going. And yet I could give you another example. 1, 1/2 square, 1/3 square, 1/4 square. Now these are very basic, simple sequence, and sequence is denoted here like this: a sub n, where n goes from 1 to infinity. N is a natural number, meaning that it's 1, 2, 3, 4, 5, 6, etc. Or we say n is an element of n. And the scripted n is the set of natural numbers, which is basically 1, 2, 3, and so on. And sometimes we express a sequence, mathematical sequence, in this way, or sometimes you would also express it as a list. So like if n is equal to 1, you'll get the first term. If n is equal to 2, you're going to get the second term of the sequence, and so on and so forth. And it keeps going. So that's the sequence in mathematics, and this is an infinite list, remember. While I am in the topic of sequence, I kind of want to touch on one topic that's kind of interesting. Even as a learner, when I was learning these things first time, I made this mistake, confusing sequence and series. They are not the same thing, okay? Many new learners, they tend to kind of think, oh yeah, kind of they're the same thing. Sequence is just the listing of the individual items, or in this context, individual numbers. However, a series is the sum of this. So series is the sum of all of these numbers. A1 plus A2 plus A3 plus ... So that's a series. And sometimes we write it as summation. This is sigma. Okay? Greek letter sigma, we use it as a summation. That means when you are adding a bunch of numbers, instead of writing them all up, you just use a compact notation. So you say n goes from 1 to infinity, a sub n. If you write it out, you're going to get exactly this. So it's going to be a1 plus a2. If n is 1, it's a1. N is 2, it's a2. If n is 3, it's a3. And it keeps going forever. And if we take the first sequence from here, it would be something like this: 1 plus 2 plus 3 plus ... And obviously you can see this sequence goes to infinity, meaning the sequence diverges. Okay? And I could use the second example, which is this guy right here: 1 plus 1/2 plus 1/3 plus 1/4 plus ... By the way, this series has a special name. We call it harmonic series. harmonic series. So this one is obvious that it diverges. However, this one is not so obvious, but this also diverges. So this guy diverges. That means it goes to infinity as you add them up. So this diverges. But the next sequence, 1 over 2 square. So, okay, 1 over 2 square plus 1 over 3 square, okay, plus dot dot dot. If I write it out as a summation notation, it's going to be this summation n is equal to 1 to infinity 1 over n square, okay. This one, however, converges. And this has a special name. This is called P series. You may want to know about it. I kind of diverted a little bit to series, even though I wanted to speak about sequence. I'll stop here. So let's go ahead and go back to our sequence. So what is a sequence? It's a list of numbers, okay? Infinite list of numbers. Now, there is a formal definition of sequence, right? In mathematics, we tend to define everything very, very precisely, or rather extremely precisely. There cannot be no exception to the definition for something to satisfy that definition. So, a sequence is actually defined as a function that takes the set of natural numbers to real numbers. So n, this scripted n is set of natural numbers. Scripted r is the set of real numbers. And of course, you know, the real numbers is just the real number line, right? 0, 1, 2, etc. -1, -2, and it goes to negative infinity on the left and positive infinity on the right. Now, what it is, it's a function that takes natural numbers, which is 1, 2, 3, 4, this set, and maps it into real numbers. So, in essence, you get something like this. F of 1 is equal to some number, and we call it A1. F of 2 is equal to some number, we call it A2. F of 3 is some number, we call it A3, and it keeps going. So you just defined a sequence A1, A2, A3, and so on and so forth in terms of function. This is probably the most precise definition of sequence. So this is the definition I kind of want you to remember and think about, and then you will get the exact mathematical definition of sequence. But as an ordinary person, you should always remember sequence is a list of things, right? List of items, etc. But mathematically, this is how we define it. Now, some of the sequences you have already seen, they converge. Those sequences are called convergent sequences, okay? Convergent sequences or sequence. If a sequence doesn't converge, we call it diverge or divergent sequence. Okay? A sequence could converge or a sequence could diverge. Now, there is a notation we kind of use for sequence, by the way. Let's say, so this is kind of like a definition. So let me go ahead and write definition. Let's assume that n is an element. So this little thing, by the way, I have been using, it's called epsilon kind of thing, but we use it in mathematics as an element of. There's a Greek letter that looks like this. So n is an element of natural number. Of course, natural number is 1, 2, 3, and keeps going. N is an element of natural numbers if limit n approaches infinity, a sub n is equal to L, okay? If this L is a fixed number, we say that the sequence converges. On the other hand, if it does not converge, we say that the sequence diverges. Now I have used this limit n approaches infinity, a sub n is equal to L. Since if you are not in calculus, you might have a difficult time kind of figuring out what I mean, but let me go ahead and kind of touch on this. Basically what it says is that n gets bigger and bigger and bigger, as big as you want. So in reality, this little n approaches infinity. If that happens to be the case, what happens to the value of this sequence? Does it approach any value? As it turns out that it does approach a value, we call it L, then we would call it a convergent sequence. On the other hand, if it does not approach a value, it could be going to positive infinity, or it could be going to negative infinity. And there is another possibility, by the way, where it could fluctuate between multiple values, two values. Okay, so one good example is negative 1 to the power n. If your n is 1, it's going to be negative 1 to the power 1, which is negative 1. If n is 2, it's going to be negative 1 whole square, which is 1. If n is 3, it's negative 1 whole cube, which is negative 1. And is going to keep fluctuating between positive 1 and negative 1. So that sequence, this sequence diverges. It really doesn't diverge to infinity or negative infinity. However, it fluctuates between couple of values. So this is an example of sequence that diverges. So you kind of have an idea of what does it mean for a sequence to converge. If the terms of the sequence get further and further and further out, that means if this little n gets bigger and bigger and bigger, and in the limiting case it approaches infinity, a sub n approaches a value, okay? And that value, if it's a fixed value, we say that the sequence converges. And the convergence of sequence is a very important thing, by the way. You may want to keep that in mind. Now, let's go ahead and talk about a couple of other things. Let me see. Let me use a different color here so that you can see things a little bit better. Now, another concept I'll talk about is increasing and decreasing sequence. So, for instance, you can see that this sequence is increasing, right? As you go to the right, 1, 2, 3, 4. Each term is bigger than the previous term, okay? On the other hand, this sequence is decreasing, okay? The previous term is bigger than the current term, or the future next term is smaller than the current term. So you can see 1 is bigger than 1/2, 1/2 is bigger than 1/3, 1/3 is bigger than 1/4. So this is a decreasing sequence. So the terms of the sequence are written as an, right? So if an is bigger than an plus 1, so if an is 1, it's going to be a1, this one. And then n plus 1 is going to be 1 plus 1, 2. So 1 is bigger than 1/2. Similarly, if n is equal to 2, we are going to be having this term. Then 2 plus 1 is 3, which is going to be this term, right? A sub 3. So, by the way, this is read a sub n and a sub, let's say if I write 3, a sub 3 or a sub 4 or a sub 1. Anyway, so if an is bigger than an plus 1, we call it a strictly decreasing sequence. Strictly. Sometimes people use the word strictly, sometimes they don't, but I tend to use strictly. So it's strictly decreasing sequence. Okay. And the other possibility is if a sub n, any term, nth term, is less than a sub n plus 1, it is called an increasing sequence, okay? Increasing or strictly increasing sequence. So we have two types of sequence, strictly increasing or strictly decreasing. Now, a sequence is called monotonic. So let me write it out. Monotonic if it is either strictly increasing or strictly decreasing. Okay? A sequence is called monotonic if it is strictly increasing or strictly decreasing. The next topic I want to talk about is boundedness. A sequence could be bounded above or it could be bounded below. Here is an example. So if you have a sequence, let's call it A1, A2, A3, and it keeps going, right? If you have a sequence A1, A2, A3, and there is a real number m, there is a real number m such that for all the elements in the sequence, all the elements in the sequence are less than or equal to m. So that means if you take any n, okay, n is the natural number, so a sub n is less than or equal to some real number m, we say that the sequence is bounded above. Okay, we say that the sequence is bounded above. So that means all the elements in the sequence has to be less than or equal to this capital M or uppercase M. On the other hand, a sequence is said to be bounded below when you have the following scenario. So there is a real number m, lowercase m, such that m is less than or equal to a sub n. And actually, here I need to be a little bit more precise. This n is an element of the natural numbers, and the same for here too. N is an element of the natural number. Doesn't matter what n you consider, okay? For any n from the set of natural number, you'll get an element of a sub n, right? And that a sub n is less than or equal to this capital or uppercase M, that means is bounded above. On the other hand, if this lowercase m is less than or equal to all the items in the sequence or all the numbers in the sequence, then we say that is bounded below. So a sequence could be bounded above and a sequence could be bounded below. Now, here is an interesting thing or interesting concept that combines the monotonic feature of sequence and boundedness. So this is something you may want to keep in mind. This is an interesting and very basic feature of a sequence. A monotonic bounded sequence always converges. A monotonic, if a sequence is monotonic plus bounded, okay, monotonic plus bounded, that means that implies that it converges. So if you have a monotonic sequence, means it could be monotonically increasing or it could be monotonically decreasing. And if it is bounded above or bounded below, then it is a convergent sequence. So this is plenty of information about sequence. I hope that this discussion was helpful. Thank you very much.